Our next speaker, Ricardo, he's a DevOps engineer at xgeeks. He's responsible for driving the infrastructure for a leading automotive company. In his talk, Ricardo will provide a DevSecOps guide to help developers prove their workflow. Ladies and gentlemen, please give a warm welcome to Ricardo.
Thank you very much, guys. So, zdravo. I hope you guys are doing great. I hope, by the way, that translator didn't trick me and I said something. I basically said hello to you. Can someone confirm that yeah? Okay. Okay, so guys, I remember starting to watch the after movie of last year's edition of VipCon and thinking, okay, this is amazing, this is a fantastic venue. This is really a place that I really want to be in. And so I feel really lucky to be here. And on that note, I really want to give some kudos to the organization, to Deep Space. I think they deserve it. They have an amazing venue. They set up an amazing conference. So can we have a round of applause for them before I continue? Okay, so who am I? So my name is Ricardo Magalhães. I'm from Viseu, Portugal. I'm a DevOps engineer at xgeeks. And I actually started my career as a software engineer working with React and React Native mainly, before actually transitioning to whatever the wonderful and amazing world that DevOps is. And along my career, I've been working in projects for a couple of banks. I've worked for companies or projects for companies in the industry, in the energy industry, the fuel industry, and most recently, I've been working in a project for one of the lead automotive companies of today. So what is going to be the agenda for today? We're going to start to talk a little bit about what gave origin to DevSecOps, why is it needed. We're going to take a look into the components of software that needs to be protected, how can we protect them. Then we need to understand what workflows or the way that we are working in our software development lifecycle. How can we bring everything together? Okay, we have our scans, we have our workflows, how can we mesh everything? And then finally, we're going to take a look into a couple of challenges and maybe even a couple of advices, I guess, for my part. And that's how we'll finish this talk. And I'm going to start with a very simple scenario. And we're going to start by meeting the team. So in this scenario, we have Nicole, which is our full-stack software engineer. Okay, does anyone want to say hi to Nicole? Okay, we got a couple. Okay, I just made you wave at a stock photo, so it's pretty cool. Then we have Paul. Paul is a security engineer. I'm not sure if it's a stressful job, but he looks 89. Then we have John. John is the boss, but really is someone from management that really wants to push the product out as fast as it is humanly possible. And then we have this guy. This guy is a DevOps engineer in Paraguay. I'm pretty sure he does YAMLs all day. I'm not sure, but yeah, he's there. And in this very simple scenario, Nicole is just finishing the work on a feature that needs to be deployed to production next week. And the team is following a DevOps approach, okay? So locally, Nicole is doing the APC of development, very, very simple. So she's guaranteeing that the application builds, that linting is okay, that unit tests are passing, and then once she pushes the code to the remote repository, that's when DevOps really starts to shine. The continuous integration is triggered, and then it's going to guarantee all the things all over again. So the application builds, linting is okay, the unit tests are passing, everything. So at this point, it looks like everything is okay, that everything is going to be able to be pushed to production next week. Nicole even has some good reviews from her colleagues, and the pull request can be merged, so everything looks okay. So she's thinking, okay, my job is done here, I can rest, and it's Friday, she's tired, so she just wants to go home for the weekend. But she checks her email just one last time before she actually does it. So this is what she gets. She gets a nice gift from Paul with a nice PDF full of security findings. And I'm not sure, can someone raise your hands if you have faced something like this, or if you still face something like this? Okay, so I don't think, okay, we have one hand, okay. This means one thing, which means that one, your DevSecOps processes are on point, or you don't have them at all, so there's no in between. And in this situation, I guess you can imagine there are a couple of problems. I don't know if you've seen them already, but we need to push to production next week. Security findings have been found in our environment, so what does this mean? Are we still deploying next week? Or Do we need to perform some mod fixes on production? There are a lot of questions that arrive in this situation. And everybody starts to panic. You start to panic, Nicole panics, Paul panics, that's why he looks 89 when he's 32 or 34, I'm not sure. This is your boss, this is your dog, because he looks at you and you're panicking, so he's going to panic as well. Dogs are very loyal. And in this situation, there's discussions that start to break loose. And one of them is more preeminent than the others, and it's one discussion that I've usually called the yes, but discussion. You're probably confused. What is this yes, but discussion? It usually goes something like this. It usually goes from, or between someone from security and someone that really wants to push the product. And it goes like this. Okay, we have to employ a mitigation plan. Yes, but, okay, here's where it goes. Yes, but we need to deliver this ASAP. We have to locate the entire team to fixing these vulnerabilities. Yes, but we need a lens on deck for the deploy. We cannot allow this in production by any means. Yes, but fast time to market keeps us on top. But at the end, they do agree on one thing, which is good. This will ruin our reputation, so that's kind of good. But in this situation, you can see that something always ends up sacrificing. You either sacrifice security or you sacrifice fast time to market. You sacrifice security, and you're pushing a product that is likely, or not likely, but can be exploited and have possible breaches, right? If you sacrifice fast time to market, your product has the chance of not being competitive nowadays. So at that point in time, you're like that guy in Godzilla movies. I don't know if you watched it, but the monsters start to awaken, Godzilla has to fight them, and you're just like watching security and management go back and forth, and you're like, okay, let them fight. But you can't do that, because as a DevOps engineer, you have a problem in front of you, you need to fix it. So, but before we actually do that, before we actually dive straight into what DevSecOps is, we need to go a little bit back into the genesis of what DevOps really is, or how it was created, what was the origin. And I don't think there's a perfect way to describe what DevOps really is. Okay, show of hands, who knows what DevOps is? Okay, 90% of the room knows what DevOps is. My name is Ricardo Magalhães. Thank you very much. Okay. So, what really is DevOps? If I ask 10 of you your definition of DevOps, I'm getting 10 different answers. But I think that's perfectly fine. I'm not sure if you guys seen Nicolas talk, but he agrees with me when he says that nobody really knows what DevOps is. Do we do cloud? Do we do cloud? Do we do infrastructure as code? Pipelines? Yeah, we do all of that and a little bit more. But why? Why DevOps? Why is it something? Okay, so the problem arises from a silo that these teams were working in, so development and operations. There was a huge gap that needed to be fixed here. So from development, and their process usually ends up with a bundle or a group of files that needs to be deployed. Once that is done, they take that bundle, they throw it to the operations team, and they're like, good luck. Okay, it needs to run now. Usually that goes with a set of instructions. Other times, it doesn't have any instructions at all, and then the operations team grabs that bundle and needs to make sure it's running, and that stays running. Okay, that's a lot of potential to go wrong, I think. And what happens in that situation if the application doesn't run? Or if the instructions weren't clear enough? Well, then the bundle goes back, or the development team needs to fix whatever needs fixing, and then then the process repeats again. So development finishes the process. There's a bundle. The bundle goes to operations, and then you repeat and repeat and repeat until you eventually go from it works on my machine to, oh my God, it's actually running on the server. Okay, that's how it ends. And with security, I think nowadays it's pretty much the same thing. Security is working in a silo, and usually this is what happens. So we got development, okay, just the basic. Then you got your normal operations tasks when everything is already running. And then there's this guy. This guy is executing security batches, who knows for how long, that no one really knows what kind of, or what chunks of code he's analyzing, but he's doing that very much in a silo. So what happens in this situation is that security ends up being sacrificed. And this is obviously a problem. Ideally, we want security testing to be part of the process and not a destination of the process, because in this case, it's the destination of the process. What we want is something, or the first concept that we can actually talk about today, which is shift left. The shift left concept is pretty much taking something and moving it to earlier stages of a process. So if I say I want to shift security left, I mean I want to execute security scans as early as I can in my software development lifecycle, right? So something like this. Okay. And with this, we get a couple of advantages. So we're performing scans much easier or much earlier, which means we're capturing vulnerabilities much earlier in our process. This means that we do not have to wait for a specific team to actually run tests on our code, who knows for how long, keeping us from actually deploying it. We're making sure that security is guaranteed much earlier, which means that if we're analyzing smaller chunks of code, instead of analyzing, let's say, 2 months worth of code, it's going to be much easier to fix whatever is found in that time slot or in that chunk of code, in that little chunk of code, as opposed to 2 months worth of code, okay? And obviously, all of this is going to build up for some improved efficiency. And I just said that DevOps can be hard to define. I mean, no one really knows. It's because of the scope. No one knows exactly where it starts, where it ends, but I guess we can define DevOps as the culture as well as the processes and tools employed to deliver better software pieces and do it faster. Is that good? Yeah, it's good. Okay. So for DevSecOps, we want all of that, deliver better software pieces and do it faster, but guaranteeing security from the get-go, pretty much. And by the end of it, what DevSecOps really wants is to combine all of this. So security cannot be sacrificed, resources cannot be wasted, and we need to achieve this trifecta that looks either the half-cut Audi logo or the Olympics game logo cut in half, but it's actually the trifecta between code quality, fast delivery, and security. Now we can look into what to protect. And when I say, or when I ask you how you would protect your software, I can pretty much ask you, how would you protect your car or your house, I guess. Let's start with your house. How would you protect your house? Maybe you set up a fence in front of it so people don't just walk in. You make sure that the walls are good, are sturdy, that there are locks in the doors. You set up some security cameras around the property. Maybe you have pit bulls and crocodiles. Or if you want something more aggressive, chihuahuas. But in protecting software, it's pretty much the same thing. You find the components that need to be protected, you understand that they can be exploited, and you start protecting them one by one. So let's start with an analogy, okay? Let's keep the house, I guess. Building software is like building a house. And building secure software is like building a secure house. Let's be a little more objective. So let's say this is our use case, I guess. So it's a very simple one. So, we start with your own code. Then we obviously have third-party libraries because we're not doing everything from scratch. We take everything and we package it into Kubernetes or into Docker. Docker is the blueprint for the pods that are being orchestrated using Kubernetes. And then finally, we have everything infrastructure being managed by infrastructure as code. So starting with third-party libraries. And this is the outside body in your code that you don't have control over. For this, you want to look into software composition analysis, or SCA. And if we're looking into the housing to protect our house, you're going to bring a contractor in. So SCA is like making a background check on these contractors. Okay, what have they built in the past? Maybe they've built a building that just fall after 3 months. Okay, that's not good. Maybe you don't want them to build your house. And software composition analysis is pretty much doing this. All of those imports that are bringing functionality in are also bringing vulnerabilities. And software composition analysis is looking to things, or is looking into packages to get things like, what vulnerabilities does it have? Does it have a license? What operational risks does it have? Okay, maybe it has 2 commits in the last 5 years. Okay, that's a pretty big no-no. Okay, no one is maintaining this code. So this is what software composition analysis is trying to do. Then we can look into your own code, which means the code that you copied from Stack Overflow, okay? I'm kidding. No, I'm not. And in order to check this, there are a couple of scans we can look into. The first one is the static application security testing, or SAST. And SAST scanning is like making a continuous check into the blueprint of your house as you're adding new things. You're adding a new wall, okay, is it going to be well built? SAST is doing exactly that. It's looking into your code files. It actually has knowledge about your code files. It's looking into them, and it's trying to find patterns of the language that you're using against the known database of actual patterns and rules that need to be followed. And if you're not following one of them, well, it's going to let you know about it. This can be a couple of things. It can be maintainability, it can be security, or it can be reliability. Then we have, also looking into your code, we have dynamic application security testing, or DAST. And DAST is like performing a stress test on your house to see how it behaves against real-life conditions. There's a gust of wind, or there's a tornado. Is your house going to hold? If I start throwing rocks at it, it's going to just start to fall apart. This is what DAST is going to try to do. As opposed to SAST, DAST does not have access to code. It doesn't know your code files. But the approach here is the approach is the one that an hacker would follow. He doesn't know your code, but he's going to try to break your application. And another difference is actually your application needs to actually be running on a server in order for you to perform these kind of scans. So this is pretty much the difference between SAST and DAST. If you ask me, okay, should I pick one or the other? Well, not really. If you want something robust, ideally you have both of them. If you want a quick win, maybe you can go with DAST because it's one that is very easy to integrate. You can do it in the next 10 minutes, probably less, and you have a full report of what's happening in your code. So if you want something robust, you go with both of them. They do check, both are checking your code, but if you want something that is actually strong, you go with both of them. Okay, containers. What is happening with containers? Containers is like checking or taking a look into the materials that you're using to build your house. Are they of good quality? If they're not of good quality, well, your house is going to be, pardon my French, crap, okay? And container security analysis is looking into your image. And your image is pretty much based, or is pretty much made of a couple of layers. You start with a base image. Let's say you're working with Node, so you're starting with a Node base image. Then you have your application code on top. Then you have other layers. You have run commands. You have your entry point. You have all of those things that are building up. And where's the problem here? Or where are most of the problems here? Most of the problems here actually come from the base image because it's the one thing that you cannot really control. Okay, you checked your code before, but the Node image that you put in there might have a lot of vulnerabilities. So most of those things are actually or in this case, actually come from the base image. So this is what container security analysis is trying to warn you about. Okay. Then we're looking into infrastructure as code. Infrastructure as code is like looking into the foundation of your house. And the foundation, like it's very explicit by the name, is actually what's holding everything together. So if the foundation is faulty, your house is going to be faulty. And infrastructure scanning is looking into your infrastructure files and pretty much trying to capture misconfigurations. You're setting everything up from the ground. So you have your servers, you have a bunch of services on top as well, and all of these can have misconfigurations that can actually, or can be possible exploits to your application, so you need to look into them. So for example, for servers, okay, do you have open ports that shouldn't be open? Maybe they're publicly available. Why are they publicly available? Do they need to be publicly available? Are we using weak encryption algorithms? Do we have rotation strategies in place? So all of these things, which most of them are big things, but there are also a couple of things like rotation strategies, is something that infrastructure as scanning is going to help you identify in your code. And then finally, this is the last scan we're going to talk about today, is how to scan Kubernetes resources. So everything that we're deploying in Kubernetes can be exploited and has weaknesses. And Kubernetes resource scanning is like performing a system check on your house. After everything is set, you want to make sure that the walls are okay, they're sturdy, they keep the house in its place. Are the alarms set? Are the security cameras operational and available? This is what Kubernetes resource scanning is doing. It's looking into your Kubernetes resources and it's trying to identify some misconfigurations in them. So maybe you're running pods as root, or maybe you're running pods as root, which as a root user, which is a pretty big no-no. Maybe we have deprecated API versions, or roles are overly permissive, or probably you have users with roles that allow you to do everything in your cluster. Maybe you have sensitive information that should be secrets instead of being config maps. These kinds of things is what Kubernetes resource scanning is trying to warn you about. And now, after everything is set, we want to make sure that it's actually set. So, and I know this is a little outlier in this presentation because observability, why am I talking about this here? Well, if there's something, or if your system is up, or if it's set, you want to really make sure that it's actually set and keeps running. So if there's a breach, if there's an incident, you need to know about it, and this is what observability is going to add you. So making a bet on observability is really the way to go. And I think, from your reactions, I think I need to explain this photo here. Okay, so what's up with the old lady? So in Portugal, it's very common for you to be walking over the streets, and if you look up over the windows, you're going to see a lot of old lady, I guess, grannies. And this is very typical in Portugal. So, and they're usually compelled to security cameras just because of this. So if there's a crime that actually happened and security cameras didn't caught it, maybe someone's grandma did. So this is very usual. Sorry? It is? Oh, okay. Perfect. What? Sniper grandma. Why sniper? I'm scared now. Should I be? Okay. Okay, that's really interesting. That's something I didn't know about Serbia. You were talking about Serbia, right? Yeah. Okay. So we finished talking about all the scans. Now we need to understand how we can integrate them into our workflows. And I chose these three because are the ones that are most used nowadays, I guess. We start with continuous integration, which is one that should include everything that is quick to execute, that provides value. And it has to be quick because you're doing 500 of these a day, so it should be quick. Continuous deployment, above all, you want it to be reliable to actually deploy your stuff. And then, of course, we can choose to have a couple of things scheduled. So let's start from the beginning. Software composition analysis. This is how we do it. I know this is a very generic example, very basic, but I think we're going to get the gist of it. Software composition analysis is very quick to execute, so it's perfect candidate for continuous integration, but you might be saying, okay, it's looking into third-party libraries. I just updated a variable, nothing to do with third parties. Why am I scanning every time I push something that is not related to third parties? Okay, schedule it, run it once a week to make sure that everything that you added over that week is perfectly fine. SAST scanning. SAST scanning is also very, very quick to execute, and it's a perfect candidate for continuous integration, nothing new here. That application actually needs to be running on a server, so we want to deploy it, so continuous deployment is the way to go. Or if you don't want to run one of these scans every time that you deploy your application, maybe you do a lot of deploys, nowadays it's perfectly viable to do this. Then make sure that every week everything is up and running, everything is okay, that you have one of these reports giving you detail about everything that is going on with your code. It's perfectly fine to schedule it. Container scanning. It's a perfect fit for continuous deployment. You build your container, you push it to the remote registry, and then you actually deploy the container. Infrastructure as scanning. It's also a perfect candidate for continuous integration, and you can do, it provides you some flexibility. So if you have these files in its own repository, you can choose to perform the scan every time you actually push into this repository, or even if you have your infrastructure as code or your infrastructure as code files together with another code base, you can say, okay, I want to perform one of these scans every time this folder that contains these files is actually updated. For Kubernetes scanning, I put this one in continuous integration and continuous deployment, but really, it's a perfect candidate for also to be something that is scheduled. Why is it good for both continuous integration and continuous deployment? Because tools that usually offer you this capability to scan Kubernetes resources allow you some flexibility in the way that you do it. So you can do it by scanning the manifest files, which is the actual blueprint of those resources. And this means you don't actually need to deploy anything before you perform this analysis. Or you can choose to actually scan your live cluster. So it's already deployed, everything is running. You can choose to point to that cluster and see exactly what is happening on that cluster. So if you actually want to stop something from being deployed, depending on the vulnerabilities that you find, you will want to use continuous integration workflow to actually perform this kind of scan. If you prefer to do it live, in a cluster, then the way to go is continuous deployment. Finally, we're going to try to very quickly gloss over a couple of challenges. And when we talk about DevSecOps, I think most of the challenges really vary depending on the maturity of the project. As you can imagine, when we're talking about culture, we're talking about tools and processes. Implementing these things in a process that's been running for 20 years, as you can imagine, is going to be a lot more difficult than a project that is just going to start next week, because people are not used to work as, are not expected to work a specific way, or are not used to work in a specific way. So the maturity really plays a huge role in here, I think. And the first challenge, it's not really a challenge, but I guess it comes in the form of an advice, which is to not integrate all at once. And I remembered when when I was finding about all of these scans, I was like, okay, I'm going to start really getting this bulletproof. I'm going to put SAST in here, and DAST, and then put everything at the same time. But these are a lot of tools. And these are just a few tools. There are more. There are more tests that you can perform. There are others that I didn't even mention. So there are things you can never substitute, like penetration testing, for example, with anything that I've talked before, or anything that I've talked in here. So this can become pretty overwhelming, and you know all of them come with a learning curve. So in here, I guess the advice is to take one at a time. Start simple, start scanning your third-party libraries, then go check your code, is everything okay, then go for Docker, and then go build all the way up to Kubernetes scanning. Plus, sometimes you can even choose what kind of problems you have in terms of, I guess, introducing these scans. If you start a project this week, maybe you're not even versioning your infrastructure yet, so you don't have to worry about infrastructure as code scanning. Maybe you don't have Kubernetes yet, so that's not a problem. But in here, the advice is always the same. Go one at a time, and start from the most simple one, which is SCA, so scan your third-party libraries, and then go all the way up to Kubernetes. Second one, and I think this one is the most important and the most arduous to actually achieve, which is building the culture. And building the culture implies actually not convincing people, but bringing people in. If people are not in on what you're trying to sell, and I'm trying to sell DevSecOps, then, well, there's nothing done here. You actually need to make people understand, or people need to understand on their own, that there are a lot of advantages into implementing DevSecOps practices, but most importantly, they need to understand what are the impacts and what are the real dangers of not implementing DevSecOps tools and processes. And this is a hard thing to actually do. So how do you do this across a company of 500 people? Or even we could go a little smaller. How do you do this in a project of 10 people? And it might be a small project, but it's going to be a hardware test, because 10 people, everyone thinks their own way. They're used to working with a couple of tools, with certain tools, and if you get there and say, okay, you're going to work with this tool from tomorrow onwards, and he said, no, if everything's perfectly fine, so why should I learn this new tool? You know, it's going to take time. Another thing that's I guess a good advice is to actually start from the top. So if you start with the team leads, if the team lead doesn't believe in what he's selling, in this case DevSecOps, then the team is not going to believe it as well. Usually the team looks up into the team lead. So if the team lead understands, that's a good step into the team actually understanding what is the real benefit of implementing DevSecOps practices. Another small advice, this is a small advice, but it's a good one. Let's say you want to spread the message across your company. Why not see if there's anyone passionate about the topic, right? Ask around. Is there anyone that loves DevSecOps? If there's a person that loves DevSecOps, why not convince him to, or why not ask him to do an internal talk about it, about the topic? And believe me, asking someone that is passionate about a topic to make a talk about it, it's not the same as as asking someone who isn't passionate about it to do the same talk. You gain two different talks, and believe me, if someone is passionate about that, he's going to be able to convey the message so much better than someone you just asked for. You know, it's really, I think this one is really a cool small one to actually try to implement. Building the culture will take time, commitment, and your sanity, but it can be done, I promise. But culture does not always have to be about the big things, about changing the entire way your culture or the entire way your company thinks about processes and tools. Doesn't always need to be big things about that. It can be small things like, let's say one of your developers is asking you to bypass the checks and merge their pull request. Building culture can also be small things like saying no to this message, because you're actually enforcing culture here. Okay, it could be small things like this one. Now, dealing with security debt, and security debt is always going to exist just like tech debt. It's there, we need to deal with it. And these are the two, I guess, concepts, ideas that I use to deal with the ones in my projects. The first one is to establish a baseline. A baseline is, very simply put, a starting point. What is the as-is of your project? Let's say you want to integrate container scanning in your project. What is the as-is of it? So let's say you've been working 5 years in a project and you're just introducing container security. You're going to find a lot of junk there. And this is your baseline. So you found 5 critical vulnerabilities, 7 highs, 10 medium, and 22 lows. Okay, this is your baseline. This is your starting point. Why is this good? Or how does this concept of baseline helps us? Because someone, or your product owner or your product manager or whatever is going to be like, okay, we need to fix it. We need to fix this right away. We need to employ the entire team to fix this. And you're like, perfectly fine. No developments for the next 2 weeks. And he's like, no, absolutely not. We need both. How does the baseline help with this? It helps you because you won't halt your workflow. You keep developing. You keep presenting things. But at the same time, you're saying that anything extra or anything additional that's going to break your baseline, and breaking the baseline is, for example, let me go back. It's, for example, let's say we found another high vulnerability, and in that scan, okay, our baseline was 7, and now we found the 8th one. That's breaking the baseline. This means you need to fix with this, or you need to fix this, or you need to deal with this immediately. But the ones that were before, you either allocate your entire team, or you're pretty much not delivering anything for the next couple of weeks. So this is where a baseline is going to help us. But just because we're not necessarily tackling everything immediately doesn't mean we can just close our eyes and be like, okay, it doesn't exist, it's secure, it's perfectly fine. We need to know how to attack security debt. And attacking security debt is pretty much understanding the way that you work. So you're working in 2-week sprints. How can I start attacking this baseline? Okay, I have this 2-week span. Okay, how many vulnerabilities, how many high vulnerabilities am I going to fix in this sprint? How many medium vulnerabilities I'm going to fix in this sprint? Is pretty much plan appropriately and create a well-defined process around this. Another concept that helps, another concept that helps is the mitigation deadlines, because it actually gives you something that you need to work towards. Okay, human beings work a lot better under deadlines. Whether it's good or bad, we work better with deadlines. So if I say that, and this is an example, usually criticals you need to fix now, not in 5 working days, but this is just an example. And let's say we have 5 days to fix critical vulnerabilities. Vulnerabilities need to fix in this sprint. This is also a guide for you to actually plan your sprints accordingly and actually start tackling your baseline. So if 5 vulnerabilities need to be fixed in this current sprint, then you have 7 critical high vulnerabilities to actually fix in this sprint. So this is where mitigation deadlines are actually useful. Then, when to break the build? And breaking the build is pretty much just saying, okay, when does this code when doesn't this code has the necessary quality, or when is it not secure enough to actually be merged into a persistent branch? This is where you say you want to break the build. And breaking the build, we take the concept again of baselines and we say, okay, this is our baseline. If we break the baseline, we break the build. We had 7 high vulnerabilities. We found an 8th one. This is where we break the build. So the baseline here is going to help us throughout defining this process that we need to set in order to tackle tech debt. Also, this is something you always have your DevOps to help you with this subject. You can always ask them, how can I fix this broken pipeline? This broken pipeline, and most of them is going to make you this very pertinent question. Did you try rerunning it? I'm joking, by the way. We would never tell you this. Did you? Okay. So to finish this up, I want to make a quick game. Okay, I have a couple of seconds. Let's make a quick game, which is when I do this talk, I usually ask people to give me three numbers of what is the perfect number to rerun pipelines without the situation just being sad. Can I have 3 numbers so we can vote? 702, okay. Who is for 7? 7 is acceptable. Oh, I'm not. 2? A lot, and 0. Okay, I think 2-1. Okay, this is just a quick game that I use to understand a little bit how people think. And you usually give this talk into DevOps conferences, but this one is a little more broad, so I actually wanted to understand how this particular group of people thought. So 2 is the one. Usually I get 3 on DevOps conferences. I got 2 now, which is interesting. To finish it all up, what was the problem? Security was being siloed from DevOps processes. How can we fix this? We employ a shift-left approach, and we actually want to streamline this into our development. Then we need to identify how our code can be exploited, and we need to understand what those components are, how can we protect them, we need to understand what the scans are, or what available scans we have, we need to understand that combining multiple ones is the way to really bulletproof your workflow. Then we need to understand the way that we are working, what workflows do we have, or what is the specific way that we're working that we can insert these scans with, and we need to bring everything together. And then we need to understand that this is talking about culture. This is a big topic. So there's going to be challenges. We need to know how to deal with them. But knowing them is the first step to actually be prepared for them. So it's good to actually know the challenges to be prepared for them. Thank you very much. I hope you guys enjoyed. And if you have any questions, I'll be around. You can just approach me. Thank you very much.